1.3, there is a lot of reviewing stuff that we've already went over. Primarily what we're going to go over in this one is a lot of definition stuff. We're going to talk about basically Venn diagrams and how to annotate them. Then you didn't need to, did you? Okay, so our Venn diagram, a normal Venn diagram is just two circles and they overlap, or they tend to overlap. So if I listed everything that I have in my classroom and everything that Miss Tibbs has in her classroom, she will have some stuff that I don't have, I will have some stuff that she don't have, and we'll have a lot of stuff that mixes in. Okay, so here let's just name these bubble A and bubble B. Okay, I can talk about this in a set, so that set builder notation that we had before can still be represented using this Venn diagram. If I let X represent just random items, again thinking about what these two could represent is Miss Tibbs' room and my room, then we can let X be any of the items that are in our rooms, and then I'd say X is an element of, that's the element symbol, remember that, is an element of A and B. Now here's the symbol that you don't know. It basically is an A without the line through it. It's a little bit bigger, upside down U, if you will. This is basically an annotation for and, so it means and. So if I said to write down the items that her and I both have in common, then that would be the things that are right here. Those are the things that we overlap on. And we've seen this before. I just need to show you what this symbol is. So that is called the intersection. You guys have seen that before, so let's write it down. Intersection, more realized by you guys as the and. Okay, if I'm talking about the and, I will use the symbol just like that. That is my symbol for and, upside down U. Let me show you what it looks like in your book. It's that right there. Horseshoe. Okay, the or one is just opposite of that. It turns it the other direction. Okay. So let's talk about union. That's the one that looks like or. So union is the one that talks about or. So that is an either or. So if I said the things that are in my room or Miss Tibbs' room, that would be everything that's in A and everything that's in B. So it's a combination of the two. So union you might think of as more of a combination. It's everything all together. And it looks like this when it's written down, just in regular U, capital. Okay, any questions there? I'll show you what that Venn diagram looks like. It's just everything. So everything would be shaded in. Okay. And we'll do some examples with this so that you can see how that's used here in a second. Is anybody still writing? Okay. Let's do a few examples of this one. We'll do example 1 from this book. Example 1 starts with a set of numbers. I'm going to shorten the set. So A is the set of numbers, and copy them as I say them. 1, 3, 4, 5, 7. Close that set. And B is the set of numbers 2, 4, 6, 8, 10. Okay, there's no real pattern right here necessarily, but there is one right there. So if I was going to draw these in a Venn diagram, I could. You don't have to, but for the sake of our first example, I'm going to. Okay, I want to identify the things that they have in common. This is A, this is B. What numbers do they have in common? Well, all of the even numbers, right? So I go through here, 1, 3, 4 is the only one. So 4 is the only number that they have in common. The rest can just be written inside of their respective bubbles. So 1, 3, 4 is already written in there, 5, and 7, right? and then this one would be 2, 6, 8, and 10. Now I can start talking about them. If I told you find the intersection, which is annotated like this, A intersects, so it looks like this, B, and that is describing a set. So you would start a set of numbers. What intersects that? 4 does. And that's it. That's the only thing they have in common. So maybe on our definition of intersection we need to put in have in common. Okay, let's talk about the union. The union will be written like this: A union B, and it's again described as a set of numbers, and it's everything that's in both of them. And typically I like to write these in order because that's the easiest way to see them, so we're going to go ahead and write them in order. So it'll go 1, 2, I'm just pulling all of the numbers, 1, 2, 3, we have 4, we have 5, we have 6, we have 7, we have 8, and then we have 10. Yes, I did. Because it's everything, it's the combination, it's all of them in either or. So I'm saying, what is in A or B? Well, 1, 3, 4, 5, 7 is in A, and 2, 4, 6, 8, 10 is in B, so I have to list all of those. I do not want anything written down twice. Okay? Nothing needs to be written down twice in that particular instance. Okay, so that's an easy one. They give you this set of numbers and tell you just to basically write them down. Any questions before we move on to a harder one? Okay. All right. On example 2, we're going to talk about either the intersection or union of two sets of numbers. So here, A, and they're going to write this in set builder notation. We'll have to pull it out of that. So it says X is the element where all of the things within this set are greater than -2. Okay? So if I wrote this on a number line, it might make it a little easier to see. I'm going to put 0 on here. I start at -2. It's an open circle, and everything is going to the right because it's greater than. So everything to the right is an answer for that particular set. On B, again, this one's written in set builder notation. It says X such that X is less than or equal to 5. Okay, and again, I'm going to put this one on a number line so I can see it. And then I'll put them on one number line and we can look at them together. So X is less than or equal to 5. And again, I'm going to put 0 on my number line. This one is a... Always, yes. I simplify your number lines to an extent that the least you can do is write 0 in there. So X is less. So less is left. It's a closed dot. And we can see the two number lines, how they might be when they intersect. So we're going to talk about the intersection. So A intersect B. Okay, remember I read this as A and B. What is the solution for A and B? Yes, Taylor? Yeah, I'm about to. I'm separating, I'm making it step by step at first. We'll go faster once we learn how to do it better. Okay, so Taylor asked, can we just put them on the number line? Yeah, sure, I'll do it right now. So -2, +5, everything in between them is going to be the solution. So I need to put a closed dot at 5 and an open one at -2. So this is what they look like when you combine them. So this is definitely an and. The intersection is basically the way that you would write it in a compound inequality, right? So how am I going to describe the set of numbers? So I'm going to describe this set of numbers like this. It is the set of elements such that, and I just write it as a compound inequality basically. So it'll look like this. Okay, and then I'll put my numbers in there. It's actually really drawn out the way we did it, but oh yes, you're right, sorry. Bad habit. Okay, so we get x is greater than negative 2, which is reflected in that drawing, but less than or equal to 5. Boom. Any questions? Here, what if I talked about... I'm about to do that. What if we talked about the union of those two? So let's look at what that is. Keep in mind that the way I would write this one in interval notation would be negative infinity all the way, that looks like an 8, I'm sorry. Negative infinity to positive 5, bracket. And this one looks like negative 2 to positive infinity. Okay? So remember that this arrow goes all the way that way, and this arrow goes all the way that way. So now what I'm asking is, what is a solution to this set of A or B? So there's a solution here is everything to negative infinity. The solution here is everything from negative 2 to positive infinity. So it would be a negative infinity. So let me write this quickly in interval notation. It'd be negative infinity to positive infinity. Okay, it's that stretch of numbers. How do I describe that as a set? What set of numbers describes all things that can be put on a number line? All real numbers. So it's the set of x such that x is an element of the real numbers. And that's all I really have to say. So x is an element of the reals. So instead of saying infinitely many solutions, we basically tell them that all the solutions are real numbers. So x is an element of the reals. Any questions there? I just took care of like 10 examples in the book. Yeah, it was ridiculous. No questions? Go ahead.
If all the numbers that it can't be less than negative 2,
See, it's asking for the solution set that satisfies either or, not both at the same time. See, so if it says is, if I said we either have less money than Kason or more money than me, that would be all number, right? I'd say Kason has $1 and I have $2. Or Kason has $0. Okay? Satisfies the whole set. Alright, here we go. Example 6, we're jumping pretty far here. It says solve this. 3x minus 5 is less than negative 2. And, so when it says and, what is our thinking? What are we using? Intersection or union? Intersection. Okay, good. So it says and 4x plus 11 is greater than or equal to 3. It says graph the solution set and write it in interval notation. Since it is an and, I'm thinking intersection. So I need to just solve the two separately at this current moment and then graph it and see what I can write in interval notation. So I'm going to add 5. I get 3x is less than positive 3. Divide by 3. X is less than 1. I have one thing down. Next, I need to subtract 11. I get negative 8. So I need to divide by 4 now. Okay, so now I have my two answers, and I write and in between them. It's just talking about the intersection. So it's saying that they should only satisfy where both of them share a common answer. So I'm going to draw this on my number line. I'm going to do it on one solid number line. Okay, always put 0 on there. Arrows and 0. That's all I require. The rest is up to you, how detailed you want to be. Okay, I'm going to put a negative 2 back here. I'm going to put a positive 1 up here. My positive 1 gets a open or closed? Open. My negative 2 gets a open or closed? Closed. Good. So for my negative 2, it says x is greater than or equal to negative 2. So I'm going to go to the right. Over here, bless you. It says x is less than 1, so I go to the left. So where do they have a common answer?
negative 2.
Negative 2 all the way to 1, right? So everything in between the two is our common answer. So it's writing this in interval notation. It goes from negative 2 to positive 1, like Haley said. Now all I have to do is decide which side gets a bracket and which side gets a parenthesis. Bracket, then parenthesis, and there's interval notation. Okay. I find it easier and more accurate to graph these really quickly, whether it be a big graph or a small graph, and then write it in interval notation. It is up to you. If you can do it without writing the graph, you go right ahead. However, I cannot. So I go ahead and do the graph every single time. Any questions? Okay, I have one more example to do with you guys. I think just one more example. Let me double check that before I say it. Yeah, I do just have one more example. And then I'll leave the last example. If you want to do it, we'll do it. If not, if you feel confident, we don't have to. This one is an example 7. It will be 9 minus 4x is less than negative 7. Or, when it says or, we're using intersection or union. Union, good. Or 5x plus 6 is less than 3, open parentheses, x plus 2. Okay? Again, I just solve them separately, so I don't really look at the or until I get my answers. So I need to subtract 9. I get negative 16. And I need to divide by negative 4. What does that do? Well, makes it a positive 4, but what does it do to my sign? It changes its direction, right? Good. So x is greater than 4. Or, now I need to solve this one. I need to distribute this 3 out first, so I'm going to get 3x plus 6. Now I can start working, right? So I would subtract 6 from both sides. I subtract 6. That goes away, so I have 5x. Now I can either decide that there's already an answer for this, or continue on down the road and subtract 3x from both sides. And I would get 2x being less than 0. Now what? I divide by 2. And I always get a wrong answer on this, so I'm going to ask it out loud so that we can clarify. What is 0 divided by 2? It's just 0, right? Good. When in doubt, use your calculator. So, I have x is less than 0, and I have x is greater than 4. We'll put this on a number line real quick. So I have 0 on here, and I have 4 on here. X is greater than 4, so it's going this way. X is less than 0, so it's going this way. Okay? So I have my two solution sets, and now I need to write this in interval notation, and this is the tougher part. Okay? Interval notation here will look a little different than what you're used to. The answer going to the left, I'm going to deal with that one first, okay, because that is where we read, left to right. And this is why I always graph them. Going from the left, I'm coming from negative infinity, right? I'm stopping at 0. Since it is less than that, I have an open circle, so that's just parentheses on both sides. On my 4, again, that's an open parenthesis, so I'm starting at 4, and I'm going to positive infinity. And both of those get parentheses. Now my question is, what do I annotate in the middle? How do I combine them two? Do I use and or? Of course I would use or, it was in the problem, right?
Well, I mean,
Okay, how do I annotate it though? The U. So, in order to write this answer, I would write it just like this. Okay, I put the U in between them, showing that it's this or this. There is no overlap. That means that the only thing that's not an answer, so let me write how this is not an answer, not solution, would look like this. From 0, inclusive, right, all the way to 4, inclusive. Those are not solutions. It may not ask you for that, but I want you to look at how that translates. Say that again. No, it'll be brackets because this does not include 4. Therefore, everything that is 4 down to everything that is 0 is not a solution. See? So if everything above 4 is a solution, then 4 is not a solution. Because it says it must be greater than 4, not or equal to. All right, now here's your option, guys. If you feel confident on absolute values, I don't need to do this example. If you don't feel confident on absolute values, then I do need to do this example. So, let me tell you what the problem is first, and you can decide from there, okay? Where did it go? Where did it go? It is 5 absolute value, 1 minus 2x, close absolute value, minus 3 is greater than 12. And it'll ask you to solve it, graph it, set builder, and put it into, did I say graph? Or am I?
Just,
Ask you to do those 3 things. Do you want me to do it or not?
yes.
Yes, okay. I can do it really quick. It's up to you.
For example, this second
17. So, in order to solve an absolute value equation, remember that you have to isolate the absolute value first. So I'm going to add 3 to both sides. Okay, I get 15 on the right now. Next, I need to get rid of this 5, so I'm going to divide by 5 because that 5 is being multiplied. So I got it by itself. Now I have this absolute value problem that I have to do what in order to solve? What happens when you have absolute values? You have both a positive and negative answer, right? So how do I convert this so that I can solve it? I put a negative 3 on the other side, and then I just copy the symbol, right? So since it's a pointing to the right, I'm a pointing to the right. So I've copied it down, and then I finish solving. After you isolate the absolute value, you just copy it down, put the negative, and finish solving. Okay, so I subtract 1 on all my sides. Okay, I get 2 over here. I'm left with a negative 2x. Don't forget about that negative right there. And I get a negative 4 on this side. Now what? Divide by negative 2. So what does that do to all my signs? Changes them all, right? So instead of that sign, I'm going to have this sign. Now they're both pointing left. Positive 2 on that one. I get an x in the middle and a negative 1 on the right. So I'm going to show you a trick to convert compound inequalities to whether they're intersection or unions. And it may work for you, it may not. This is left, right? They're pointing left. Left goes with and, so I'm going to show you how to do that. You put left goes with and. So when you think left, think land, and you'll put them together. It works. It's stupid, but it works. Left goes with and, so think land. Okay? And the other way that this works is when I graph this, look what it ends up looking like when you graph it. So I need to graph a negative 1 and a positive 2. Should go that way. So I have an open circle on both of those. Oh, shoot, that's not working. Why is that not working? Well, that might have been a bad example. Here we go. Let's just do graph it, and you'll know the difference between them anyways. X is less than negative 1, so left is less, right? X is greater than positive 2. Goes to the right. So that ended up being an OR problem. Huh. That's the first time that has not worked for me. Sorry. Bad example. When you graph it, you can tell anyways. ORs go in opposite directions. Ands go together. They create land, which is why it always worked. Anywho, to write this in interval notation, you start at negative 1. Or sorry, you don't start at negative 1, you end at negative 1 from negative infinity. And then you start at 2 and you go to positive infinity. I put parentheses next to my infinities. Because these are open, I'm going to put parentheses next to those guys. I'm combining it with what symbol? An OR. So that is upside down or regular? upside down.
Regular.
This is regular?
Upside down.
Yeah. Remember, I talked about it as a U, not an N. So maybe I'll say U and N. Will that help you?
Yeah.
Okay. So U is union. A is and, right? U makes union. All right, there you go. Sorry for any confusion I caused.